In each diagram shown in this problem, the number on the line connecting two circles is the sum of the two numbers in those two circles. Example of a completed diagram is shown to the right. What is the value of x? Well, let's go through this. So this right here I'll just call a. So according to the definition, a plus 4 is equal to 13. So that means that a is 9. So we'll just put a 9 in there. And very similarly, if this is b, b plus 9 would be 10. And therefore that means that b is 1. And therefore x is basically 1 plus 4. And that means x is 5. With justification, determine the value of y. So the same kind of story here. I guess we can call this guy x in here and then keep going with our definition. So 3w plus x would be 48. So x would be, I guess, 48 minus 3w. And then similarly, if you look at any of the other connections, x plus w would be y. And I guess the other one would give me 3w plus w is y, so 4w is y. Okay, so now where do we go from here? We got to substitute, I guess, something into something. So x plus w is y, right? So let's put everything into that equation. Or any way you want to do this, actually. I mean, there's several ways to proceed. I'm actually thinking of just using this and putting it in there. So that would mean x plus w is y and y is 4w. So that means x is 3w. And then once I have that, I can just go back and put that in there. So if x is 3w, then that means 3w is equal to 48 minus 3w. And therefore 48 is 6w. And therefore w is equal to 8. And then what they wanted us to figure out y, right? So I guess plug it back into there. So 4 times 8 is y, and therefore y is 32. So however you want to do it, as long as you arrive at 32, you're good to go. And now we got the last one. With justification, determine the values of p, q, and r. So let's set up our equations. P plus r is 3. And then p plus q is 18. And then r plus q is 13. Like that. So, I guess just isolate for some variables here. So r is 3 minus p. And then q is 18 minus p. And then sub those guys into here. So we would have r plus p, so that's 3 minus p plus q, which is 18 minus p, is 13. And therefore, let's see here, 21 minus 13, so that's going to be 8. 8 is equal to 2p, and therefore p is equal to 4. And we therefore can easily figure out the values of r and p. R would be 3 minus 4, so that's negative 1. And q would be 18 minus 4, which is 14. So there you have it. Those are the values for p, q, and r. Consider the equation x squared minus 2y squared is 1. There are many positive integers that satisfy that equation. Determine a pair of positive integers xy with x less than or equal to 5 that satisfies the equation. So x less than 5, right? So let's say here x and y. X less than 5, okay? Well, I mean, you can just start subbing in values, 5, 4, I'll let you do that, and you're just putting it into there. When x is 3, it becomes 3 squared minus 2y squared is 1. So that becomes 8 is equal to 2y squared. And then that would basically give me 2 for a positive value of y. And I think that's sufficient. They just said a pair, so that's good enough, I guess. Part B says that you need to determine a pair of positive integers uv such that 3 plus 2 root 2 all squared is equal to u plus v root 2. And then show that uv also satisfies equation 1. All right. So 3 plus 2 root 2 all squared is equal to u plus v root 2, like that. And then we have to eventually show that u squared minus 2v squared is equal to 1. That would mean it satisfies that initial equation. Okay, so let's expand this. When you expand this, we get, let's see here, 9 plus 6 root 2, so 12 root 2 plus 8, right? Yeah. And that equals u plus v root 2. So this is 17 plus 12 root 2 is u plus v root 2. So that means that u is 17 and v is 12. Correct? And then we have to show this. So u squared is 17 squared minus 2 times 12 squared. So that is 289 minus 288. And that is indeed equal to 1, which is what we needed to show. So we showed what they wanted us to do. Part 3, suppose that a and b is a pair of positive integers that satisfies that equation. Suppose also that c and d is a pair that satisfies that. Show that c and d satisfies 1. So same kind of thing, I think. We just take this guy and let's expand and see what happens. So when we expand, we get 3a plus 2a root 2 plus 3b root 2 plus 4b plus 4b, and I think that's it. Yeah, and then the other side is c plus d root 2. Okay. Now I think I'm going to group some stuff here. 3a plus 4b, and group it in that bracket, and then the root 2's I'll group. We got 2a plus 3b, I believe. Yeah. And that's c plus d root 2. So matching. Matching. What am I trying to match here? Well, this is this, I guess, right? So 3a plus 4b is my c. And then what's in front of the root 2, which is 2a plus 3b, is my d. Okay. All right. And where do I go from here? Okay, I guess they just want us to now just take those two values and show that it satisfies equation 1. Okay. So equation 1 was this guy right here, right? This x squared minus 2y squared is 1. Okay, so they want us to show that c and d satisfy that. So they want us to show that c squared minus 2d squared is 1. Okay, shouldn't be too bad. So c is 3a plus 4b squared, and then minus 2d is 2a plus 3b squared, and we got to show that this is 1. Okay, so expand it out, and we get 9a squared plus 24ab plus 16b squared, and then minus 2 times 4a squared plus 12ab plus 9b squared. And then when you collect all like terms, blah, 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 you will get a squared minus 2b squared. And that by definition is 1, since a and b is a positive, is a pair of positive integers that satisfies equation 1. So I think that's pretty much all that they wanted us to do. And then finally, D. Determine a pair of positive integers xy where y is greater than 100 that satisfies equation 1. All right. So what we just did in part C was show that if A and B satisfy equation 1, C and D satisfy equation 1. So if you choose any A and B that satisfies equation 1, then you can have C of this form and D of this form, and they also satisfy equation 1. So if you remember, we had figured out that 17 and 12 satisfied equation 1. So I can sort of say that my A is 17 and my B is 12. And that they satisfy equation 1, which we already proved earlier. So therefore C, which would be 3A plus 4B, which I guess would be 3 times 17 plus 4 times 12, which I think is 99. And then D, which is 2A plus 3B, which would be 2 times 17 plus 3 times 12, which is 70. These are also, this pair, 99, 70, would also satisfy equation 1, so 99, 70. But they want a value greater than 100 for y. Okay, no problem. I can just keep extrapolating that using this formula. So if these two satisfy, then I can create another 3c plus 4d. You see what I'm doing? Using that formula. So this is going to be 3 times 99 plus 4 times 70, and that is 577. And then I can do that 2a plus 3b part. So that's going to be 2 times 99, and then plus 3 times 70, and that is 408. So this 577 and 408 also satisfy equation 1, and this gives me a y value greater than 100. So that would be sufficient to answer this question. Right-angled PQR has PQR is 90, PQ is 6, QR is 8. If M is the midpoint of QR and N is the midpoint of PQ, determine the lengths of the medians PM and RN. Well, let's draw it. It's a right-angled, so it should be pretty straightforward. There we go. So we label this P, Q, and R. And then we've got some midpoints, so we'll call this M, and we call this one N. And let's connect the dots here. And there we go. Okay, not very straight lines, but that's okay. So PQ is 6, right? So that means this guy is 3, and this is 3. And then QR is 8, so QM would be 4, and that would be 4 since the N and M are the midpoints of those two. Okay, so what do they want us to do? The lengths of PM and RN. So PM squared would be PQ squared plus QM squared, right? Basic Pythagoras. So what's PQ? 6. So 6 squared plus 4 squared. So that's going to be 36 plus 16, so 52. So 52 is PM squared, so therefore PM is root 52. And in a very similar way, we would do the other one, RN. So RN squared would be, I'm just going to write out the numbers, 3 squared plus 8 squared. And that's 9 plus 64, which is 73. So Rn would be root 73. And that's it, I believe. Okay, part B. DEF triangle has two medians of equal length. Prove that DEF is isosceles. Okay, so let's put this on a coordinate axis. So I don't know what this triangle looks like, but let's just put it like that for now. So D, E, and F. Okay. And similarly, we got to create the medians. So this is going to be M, and this is going to be N, like that. And then let's connect those two guys, like this, like that. And we're going to have to put some coordinates here. So for E, I will call it 2B0. And I'm using 2B because that way I can call this guy B for its x coordinate. And then for D, I will call it 2A0. And then similarly, the x coordinate for N would be A, since it's the midpoint. And F I will call 0, 2C. And that for the y coordinate for M would be C. And the y coordinate for N would also be C. So that's the setup. And now we can calculate the lengths. dm, which is the first median, it would be basic Pythagoras again. Or not Pythagoras, sorry. The distance formula for a line. So it would be, let's see here, 2a minus b all squared plus 0 minus c all squared under the square root sign. And this is 2a minus b all squared plus c squared. Okay, and then En, which is the other guy, that would be 2b minus a all squared plus 0 minus c all squared, like that. And this would be 2b minus a all squared plus c squared, like that. Okay, so we are trying to show that it's isosceles, right? So if it's isosceles, that basically means that dm, hold on one second. Let me go back to the original definition here. Two medians of equal length. Okay, so let me just concentrate on that here, and then we'll talk about the isosceles. So two medians of equal length basically means that dm is equal to En. And if that's the case, then we can just go ahead and just look at the squares. That way we can get rid of the square root signs. So dm squared would be 2a minus b all squared plus c squared. And then En squared would be 2b minus a all squared plus c squared, like that. Okay, and then let's see here. So the c squareds cancel on both sides, and we expand this, we get 4 minus 4ab plus b squared. And then on the other side, we get 4b squared minus 4ab plus a squared. And then the minus 4ab's cancel. So I think we just have 3a squared on this side and 3b squared on this side. So that basically means that a squared is equal to b squared. So that means a is equal to plus or minus b. So we have either two scenarios, either a equals b or a equals minus b. Now if you go back to the diagram, a cannot equal b because they're on either side of the axes. So that means a equals minus b is the only way. So if a equals minus b, then that means df and ef are equal. Right? df and ef, because if this is equal to that, then they're pretty much equal in length, and therefore that triangle would be isosceles. And therefore triangle, what is the name of that triangle again? DEF. Yeah, DEF is isosceles, meaning they have two sides that are equal. Part C. Triangle ABC has its vertices on a circle of radius r. If the lengths of the two of the medians of triangle ABC are equal to r, determine the side length of triangle ABC. So I think we have a scenario where, let me just draw this first. Let me just see what kind of scenario I'd have. So we got some triangle, and it sits inside, so they've got A, B, and C, and it sits inside a circle. And that circle has a radius of r. And what are they saying here? If the lengths of two of the medians are equal to r, determine the side lengths. All right. Well, we're going to have three scenarios then. We're going to have a scenario where the angle is 90 degrees. Another where angle ABC is less than 90 degrees. And the third scenario where the angle is greater than 90 degrees. So let's go through each one and let's see what we get. So the first scenario number one, where you have it's equal to 90 degrees. So that means, what does that mean? It actually means that if it's equal to 90 degrees, that would mean that it's in the semicircle, right? Because any triangle drawn in a semicircle, the angle would be 90 degrees. Like that. So this is sort of, let's say, the O origin. Not origin. The center, I guess. I should have labeled it C, but you guys understand. And then this is, well, however you want to label it. I guess we can just call it ABC. Yeah, that's the proper labeling. Okay, so this is the scenario number one. So we got to, what do we have to prove here? We have to prove something. Determine the side lengths. Okay. And then the only thing we're told that it's the radius is r. So that's r and that's r. So O to C is r and O to A is r. Okay, oh boy, where do I go from here? Okay, the first thing, of course, let's just draw in the medians. And we got to label them. So I'll just call this guy M and this guy I'll call N. And let's connect them. So those are the medians. And they're telling me the two medians are equal to r. Okay. So that means in my diagram, AM, which is the first median, is equal to r. And CN, which is the second median, is also equal to r. Okay? So that's the initial. And then we just did from part B of this question, which is right up there if you can see it. If two medians are equal, that means that it's isosceles, the triangle. So that basically means, therefore, that ABC is isosceles. Isosceles. And from the diagram, it looks to me that AB would be equal to BC. Okay. All right. And without making the diagram messy, I'll just draw it right here. And if this is equal and this is 90 degrees, then this would be 45 and this would be 45. And then the ratio of the sides would be 1, 1, and root 2. Yeah. Okay, so then AC, which is the diameter, is 2r. And the ratio of AB over AC, according to what I have over here, would be 1 over root 2. So since AC is 2r, we can get what AB is in terms of r. So AB would be, AB over 2r would be 1 over root 2. And therefore AB would be, what would it be? I guess if you cross multiply, it would be 2r over root 2, which is the same as root 2r. Okay. Okay. AB is root 2r. But I think this is a contradiction because the median AM is equal to r, right? And we need to have AM, because it's a median, it's got to be greater than AB, right? If you look at the diagram, AM has to be greater than AB. But what we got was that AM is r, and AB is root 2r, and root 2r is not less than. So it doesn't work. So we have a contradiction. Contradiction. diction. And therefore what that basically means, a big long song and dance, is that this first scenario is invalid. So this guy, where we set it equal to 90 degrees, is not possible. So that's pretty much what we did there. Okay, let's move on to the next scenario where angle ABC is less than 90. So angle ABC is less than 90, so we've got this circle. This is scenario number 2. So if it's less than 90, it's probably going to be something like that. So we have A, we have B, and we have C. And then same kind of thing. Hold on here. I think I should have make this a little bit so that like that. I think that's a little bit better. Okay. So now we want to label this A, B, C. And then I'm going to draw a perpendicular down like this. And then let's put in the median. So put M here. And let's drop a perpendicular down there. And then connect that guy. And, okay, this is not going to be drawn to scale, unfortunately. Yeah. Because I believe that O would be below the line. Okay, so I think this should be sufficient enough to explain it. So we got ABC here, and then ABC, the angle in this scenario is less than 90. And then this dot here is O, the center of the circle. And then this is M, one of the medians. And then we've drawn a little perpendicular there. We've drawn a little perpendicular there. We call this point P and call this point Q. And I think that should be good enough. Okay, so now let's label this stuff here. Well, we know from part B that it's isosceles. So AB is equal to BC. And I'll let O to P equal X. And then O to A, that is the radius, right? Yeah. So this guy right here, that is going to be a radii. So, and they've told us that's R. Okay. So then AP, we can figure out easily with Pythagoras. AP squared would be R squared minus X squared. So then AP would be the square root of that, R squared minus X squared under the square root sign, like that. Okay, so that's the first part. And then we can also use the fact that we have similar triangles. That triangle MCQ is similar to triangle BPC. Yeah. Okay, so we also know that BC is equal to 2MC, right? Because M is the midpoint. And then PC is equal to 2QC, because Q drops directly down from the midpoint. And therefore, QC would be PC over 2. And then BP would be 2MQ. Yeah, this is all logical, considering that M is the midpoint of BC. And therefore, PQ would basically be PC minus QC. And therefore, that would be PC minus PC over 2. So that's PC over 2. And since PC is the same as AP, right? Because if it's an isosceles triangle and you dropped a perpendicular and it came to P, then AP would be the same as PC. That's AP over 2. And then AP we just figured out here. So we can conclude that PQ is this R squared minus X squared square root all over 2. Okay. And then we also know that B to O is the radius. And O to P, well, we had labeled that as x over here. So, therefore, let's see here, M to Q would actually be BP over 2. I think we did that. Oh, it's right here, actually. And therefore, BP would be BO plus OP, so it'd be R plus X all over 2. Yeah. Okay, that's a pretty good setup, actually. Now let's see where we can go from here. Now we have to figure out in triangle AMQ, that triangle, it's actually a right triangle, that AQ squared plus MQ squared is equal to AM squared, like that. And therefore AQ, it's going to be AP plus PQ all squared. And then MQ, well, this is MQ. So R plus X over 2 all squared. And then AM squared, what's AM squared here? Oh, remember the question tells us that the medians are equal to R. I forgot that. It's been so long now. Let's see here. The lengths of the two medians are equal to R. Okay. So therefore, AM, which is a median, is equal to R. So it's R squared. Okay, got it. All right, so now let's concentrate on AP and PQ. AP is from here. Remember this guy? So that's R squared minus X squared square root. And then PQ is right here. So R squared minus X squared over 2. And that's all squared. And then we got this R plus X over 2 all squared. And that equals R squared. So this is my monster equation. And we'll break it down. So there is the breakdown of that. Once we, do everything, expand, collect like terms. And when you get down to the final, it's a pretty nice result. And when you get down to that final nice result, we have a decision to make. Either R is equal to X, which it's not, because R represented OP, and R represented OA, and which is the radius, and OP is representing X. So according to the diagram, X cannot equal R, so that is not possible. So the only other possibility is that 3R should be equal to minus 4X, but that's also not possible since X and R are positive distances, so one can't be a negative distance. So therefore, and also if R was equal to X and you subbed it back into here, AP would end up becoming 0, and obviously that doesn't make any sense. So since nothing makes sense here, again, this is another invalid. So angle ABC is not less than 90. So that was this scenario, right? This one right here, where we had made it less than 90. So that's no good. So now we have only one final, that is making angle ABC greater than 90. So here's our final scenario, and something's got to work sooner or later, so I'm confident that this should work. We have ABC this time, and the angle ABC is greater than 90. So very similarly, they'll let this be the center. We'll call that O. And let's do some labeling here. Let me see how I can do this without making this diagram too messy. Let me first just draw a line from okay, I think this is a pretty decent diagram. Let me just label it here. First, we're going to draw these right angles. This is my median M. I got the O in there. This point here is P, where that touches AC. And then I think that should be good enough. So AB we know is equal to BC since it's an isosceles triangle. That's been established already. And then OP, I will call X again. OA is the radius, so that's R. And then the median AM, according to the question, is equal to R. And I think off we go. So AP, according to Pythagoras, will be, let's see here, R squared minus X squared. Yeah, if you look at that triangle APO. And then MQ, that's going to be, where's Q? Oh, I got to draw out that Q there. MQ is BP over 2, right? Because BP is the full top to bottom and M comes from the midpoint. And then BP is really just, let me think about this, R minus X, right? Yeah, R minus X. And then we got to put that over 2. And then PQ, that would be basically half of PC, because it's coming down from M, which is the midpoint. And therefore, that's really just half of AP, since AP and PC are the same. Okay, so that's the setup. And then triangle AMQ, we're going to have AQ squared, Pythagorean relationship, plus MQ squared is equal to AM squared, right? So very similar, actually. This AQ is AP plus PQ. And then we just got this stuff. And you just sub it all in. So AP is this R squared minus X squared. PQ is this AP over 2. So it's R squared minus X squared all over the root sign over 2. And this is all in brackets. And then MQ is R minus X over 2, all squared. And then AM is R, so that's R squared. So very similar. And then I'll let you guys do this very fun mathematics. And when you do ... you get it all, simplified. It comes down to 3R minus 4X. And then you get an R plus X, all equal to 0. So that means either R is equal to minus X, or it means 3R is equal to 4X. Now this scenario is not possible because R and X have to be both positive, so one can't be negative. But this one is possible. So this gives me that X is equal to 3 over 4R, and that is a very valid finding, finally. So now we can go back and figure out what is AC and all that stuff. The lengths of the sides, AB, BC, and all that. Yeah. Okay. Well, what would be AC? AC would be 2AP, right? Let me just do it up here, since it's already up there. And with this finding here, X is equal to 3 over 4R. So X is equal to 3 over 4R. Okay. So let's figure out the lengths of the sides now, which is what we wanted to do, finally. So AC, that's the first length, is 2 times AP. And AP is this guy right here. So that's going to be 2 times R squared minus X squared. And X is 3 over 4R all squared. So that's going to be 9 over 16. So 9 over 16, 1 minus 9 over 16 would be 7 over 16. Is that right? So 7 over 16 R squared, all under the square root sign. So that's going to be 2 times root 7 over R over 4. So that's going to be root 7 R over 2. Root 7 R over 2. So that's AC. Okay. So we got one value. And then what's the other one we have to figure out? We have to figure out the other two sides, AB and BC. But they're equal, so if I figure out one, I'll be able to figure out the other one. So let's just calculate AB. What is AB? So how do I do that? Let's see here. AB, just using Pythagoras, I guess. AB would be AP squared. Well, AB squared would be AP squared plus BP squared, right? Yeah. Okay. I think this should be good enough. So AB would be, what's AP? Where are we going here? Oh, here it is. AP is this. So r squared minus x squared. All right, let's do this carefully here. I don't want to mess this up. So we have AP squared. So AP is this guy right here, right? So AP squared would just be r squared minus x squared. And then BP, where's BP? BP, somewhere. Here it is. BP over 2 is r minus x over 2. So BP is just r minus x all squared. All right. Okay, so let's see what that leads us to. So AB squared would be r squared minus x squared. Oh, let's put in the value for x. It's this guy, right? 3 over 4r. So it would be, if you square it, it would be 9r squared over 16. And then this guy, r minus x, 3 over 4, 1 minus 3 over 4 would be 1 over 4, so that'd be r over 4 all squared. Okay, so this one looks like 7r squared over 16 plus r squared over 16, and therefore that's 8r squared over 16, and that's r squared over 2, and therefore AB would be the square root of that, so that'd be r over root 2. And then you can just sort of, what is it called? Rationalize the denominator. So root 2r over 2. And that's it. And therefore that's also BC. Root 2r over 2. So root 2r over 2 are the values for AB and BC, and AC we had calculated as root 7 over 2r.